assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for this problem, we're going to be calculating how many photons we need to raise the temperature of a cup of water. So there's going to be a couple different steps to this. First thing we need to do is calculate energy. And so the equation we would normally use is HC over lambda. So H is our constant of 6.626 times 10 to the negative 34th. C is our speed of light constant, 3 times 10 to the 8th. And then our wavelength we were given is 15 centimeters. And so we're going to just convert that into meters by dividing by 100. So we would get 0.15 meters. When you plug that into your calculator, you get an answer of 1.324 times 10 to the negative 24th joules per photon is going to be our unit. And so the next step is going to be a new equation. It's our to calculate the energy needed to heat the water. And so that is going to be our specific heat multiplied by the mass multiplied by the change in temperature. So the specific heat of water is 4.184. The mass that is given to us is 350 milliliters. And then the change in temperature, it goes from 20 to 95. So that's an increase of 75. And when we multiply that out, we get an answer of 109,830. So our last step is to divide those two answers. We're going to do the energy that is needed to heat the water divided by our joules per photon. So 1.324 times 10 to the negative 24th. And when we divide that, we get our number of photons of 8.3 times 10 to the 28.